Hello and welcome back to the Oxford Online Maths Club. My name's James and today I'm joined by Tamio.
Hello.
Hey, so Tamio is current DPhil student in the computer science department. I think I've got that right.
Yeah.
Before you were a DPhil student here doing your PhD, where were you before?
Still at Oxford, still doing computer science.
There you go. Right, all the way through, I guess. If you want to join in as well, if you're watching live, you can join in the live chat down there, where it's that's at slido.com/OOMC. That is where you can say hi, like Jack and anonymous person have done already. Oh, that's right. You can be anonymous if you join in at Slido, and that's also where we run polls, like the one that asks how your day was today, which I'm gonna run in a second. Shrist has got an offer for CS and philosophy. Congratulations, Shrist. Shrist has been joining in the Matt livestream last term as well. That's now going to come to Oxford. And somebody else says they're rejected from Oxford, but still nice to be here. So that's easy. Duality. There we go. Right. Okay. Let's do the thing. How was your day today? I should also say hi if you're joining us from It All Adds Up, because you came to an It All Adds Up event and I clumsily promoted a live stream while you were at the event. We've had this event in the building at the moment and it's super awkward having to say, oh, hi, if you want to see us online as well. Then we're going to do, because they're at an in-person event and then we can do this online thing as well. Good. There were some other chat messages there as well. What did people say? Someone said they were at It All Adds Up, too shy to say hello, but big fan of Maths Club. So, okay. Hi, welcome. You're anonymous in here as well, so I still don't know who you are, but hi, good to see you. Tamia, how was your day today on a scale from 1 to 5?
I scaled from 1 to 5, maybe a 4.
Ooh.
Started a bit slow, but picked up towards the end.
Picked up towards the end? That's pretty nice. I think I'm having a 5-star day because I've had another day of people visiting in the building, which has been rather nice. We can see in chat how people are doing. They get to vote for 1 to 5. And so far, people are having a 5-star day. I wonder if that's people doing all right. Oh, one vote for 4 stars so far, which is still pretty good. I'm going to leave that running for a moment. I've got some business. While people are joining in and getting in chat, I guess I wanted to say what we're up to. We're going to do puzzles. I've got some puzzles on the screen. We're going to do one of these. And I've got Tamio here partly because you're linked to puzzles. Do you want to explain what you do for the Invariant Society and maybe what the Invariant Society is?
Yeah, so the Invariant Society is Oxford's mathematics society, essentially. But as you can see with me, I'm a computer scientist, so anybody can join whether or not they're studying mathematics. You just need to like math. And I am one of the 3 puzzle masters for the Invariant Society. What that means is we have a couple of events per term, which include having various mathematical puzzles to solve. You know, while people are socializing, eating pizza, sitting around in the math department, we distribute some nice puzzles and they solve it while they socialize.
Nice. Yeah, so we've got some puzzles. You've got some puzzle masters. Do you do puzzle events? You were telling me before you send everyone lots of puzzles as well. I've remembered as well. I want to do a shout out quickly to Cassie in chat, who is moderating chat as well, as to how chat messages get moderated without me having to click on anything. Thank you, Cassie, if you're watching along as well. If you're in chat, say hi to Cassie. With an I and an E. Right, good. Okay. I sort of feel like I've accidentally doxed Cassie there, but people should say hi. Rocket says loves Maths Club. Brilliant. Right, good. Okay, should we do a puzzle? We should probably get stuck in, shouldn't we? I think this is Maths Club. Let's go. So I'm on the Jane Street website. I just want to be clear, we're sponsored by Jane Street. They've given us some money, but they didn't make this a condition of doing this. In fact, they don't know that I'm doing one of their puzzles on the live stream. I just was on their website, saw they had puzzles, and now I've stolen them to use as content. If they're watching, then they're finding out live which one I'm going to do. Good. Sponsored by Jane Street. If you want to find out more about Jane Street, I guess you could look at their website, which is how I found out more about Jane Street once they started sponsoring us. Right, good. Okay, let's have a look at this puzzle. So we did one of these before, quite a while ago on the stream. We had this puzzle where it was all game pieces from this game. Do you know code names?
Yeah.
It's quite it's one of those sort of word games, I think, code names, where you've got cards that based on there's different words and you have to find connections between them. And the puzzle was really fun. The previous episode it involved looking at the same thing lots of times, which is perhaps what's going on in this one as well. Here's how the puzzle works. All we get is a picture of a really messy table and some text underneath. The text says, "Oh no, the elves in charge of board games only managed to complete a couple of sets before they were distracted by playtesting the toys. Ho ho ho, how infuriating." And then the answer to this puzzle is a single word, which, well, it looks like most of our task here is going to be to work out what on earth the puzzle is. And for people who have read that and thought, hang on, I clicked on this because it said Maths Club and I was expecting maths, I promise that there is some maths coming. But for at least 5 minutes, we're going to have a go at working out what on earth is going on with this puzzle. I've got a version where we can zoom in quite a lot, so I'm going to switch over to the version where we can zoom, which is in here. I hope this is working, by the way. People will probably let me know. Oh, I've remembered. Well, this is going to be a little bit awkward, but we're going to do this slightly out of sequence. I've remembered I have these boxes. A numbered list. Tamio, my numbered list failed me. I didn't look at it. I made a numbered list of what we were going to do, and then I did not look at it. I want to show. Joe sent in some work. If you remember last week, if people were watching last week, there was some integration and differentiation, and I suggested you could try this at home. And Joe tried that, and also sent it in. They drew a function, put some rectangles underneath to integrate it. Plotted the integral. As you change the upper limit, you get different results for the integral. And got this graph. The fundamental theorem of calculus says that if you differentiate this one, you should get back to where you started. So they had a go at that and got back to this shape, which kind of looks like the function they started with. They plotted both, and so there was a bit of a difference, but yeah, I think it's broadly the same shape, which is nice. So thanks, Joe, for sending this in. Do you do much of this in computer science? Is this the sort of thing that you might care about?
Of course, this kind of finding numerical solutions, approximating answers, seeing what things work in practice, and then evaluating that kind of stuff is very important.
I'm going to write that down. Numerical work. Yeah, actually trying it for a specific example and doing it. Integration 5 for the mathematicians is an infinite. It's a limit of infinitely many rectangles. Well, a computer can't deal with infinitely many rectangles, so try doing it with just a few. Right, good. Okay. Thank you, Joe, for sending that in. If you're in chat, let us know. Maybe not. Oh no, there you are. There you are. Yes, no, Joe is in chat. There you are. There you go. If you'd like stuff to appear on the stream, you can send it in. There's an email address on screen somewhere if you want to send in work that you've done for Math Club or suggest things or goodness knows, anything like that. Right, here's this very messy board game table from the puzzle page, including some lovely tiger wallpaper. Spoilers, the tiger wallpaper is not part of the puzzle, but I do think it's nice. Maybe that's what working at Jane Street is like, tiger wallpaper everywhere. I guess my question is, if you look through the mess, what can you see? Which is kind of a leading question, but there is something to see. I can zoom in on bits of it if you like. I don't know if that helps. Let me know in chat. If you want me to zoom in on a bit of the mess, where can we zoom? And again, I promised there's some maths coming. Right, okay, I like that. Tell me, have you spotted anything? Chat's got one idea.
I just feel like if you look at the cards from every game, they look like some of them might be spelling something, but I'm not sure what it spells exactly.
Yeah, an anonymous person says in chat. By the way, I sometimes fall for the trap of thinking that all the anonymous people are the same. Sort of one hyper intelligent chat user called anonymous who can always has the right answer. And they say if you squint, the cards sort of say it's. And now I've got to reveal a little bit that I can't spell because I'm going to try and point at what they're saying, right? So highlighter. Mostly it's I can kind of see an I over here, right? And Enora says there's a GM. Possibly they've seen this G over here. And an M? Where's the M? Oh my goodness, right. So these ones. Like some massive M. Cool, okay, so we spotted that the layout of the puzzle pieces, or the game pieces that go with the same game, are maybe letters. Yes, parts of the same game make a letter, says Trisht. What does Aaron say? Sorry. Each board game has a corresponding letter made of its cards. Yeah, so some sort of order. Aaron's got an idea of what order we should put these letters in. I'm just drawing over the top of board game pieces. A small S over here, that looks like an N. And then these chess pieces form a kind of O.
Yeah.
Tell me, have you spotted what order we should put these in? I don't know how
Well,
clear it is.
it's not clear to me from the letters, but maybe it has to do with the background.
Right, yeah, so we do have this stuff in the background, not the tigers.
Yeah.
I do love the tigers. But there's this collection of bits and bobs in the background. So O is the chess pieces, and there's a chessboard in the background, which kind of doesn't need to be there, right? Like, I know what a chessboard looks like. We've got a 3 on it, maybe that's relevant or not. If we put an O on top of here, on top of the chessboard, maybe we can pair them up like that. So now, the reason I've got Puzzle Master on is because I think you might be better at recognizing which game is which. Because I think that's part of this puzzle, is to pair up O is chess, I can do that one. And then, oh my goodness, right, I think I need to erase these and think about what they are.
The left eye is Catan.
Yes,
that I know.
That looks like Catan. So I'll put the eye, I'll move that over onto the Catan box.
Risk, I think it might be the tiny S, but I can't see.
So tiny S, let me zoom in on
tiny S is Monopoly, sorry.
Yeah, so there's a hat and things like that.
Yeah, so the tiny S is the Monopoly board. I've never played Risk. Actually,
neither have I.
Okay.
Yeah, Inora knows Sushi Go, so that's these ones over here, the ones with the sushi on.
Yeah.
I played Sushi Go for the first time over Christmas, which is, I don't know how it took me so long to get around to playing Sushi Go. I would recommend. Good game. Okay, where's the Uno? I should be able to spot the Uno, right?
The Uno is the big M.
Yes, that big M. Yeah, there they are. So there's this M over here. And then neither of us on the stream have played Risk. So if somebody in chat has recently played Risk and can spot which of these cards or game pieces belong to Risk, I've got this this S over here is letters, but I've also got this N over here. So I've got 2 sets of letters.
Well, I think the N letters have scores on them.
Yes.
Which reminds me more of Scrabble.
Yeah, there's a picture of Scrabble pieces on the Scrabble, helpfully.
Yeah, and the other one is probably bananagrams.
Yeah, bananagrams is the bananagrams bag over here. It's again another word game sort of thing for people who like that sort of thing. Getting a bit harder. Clue we should be able to do. Clue is the one with you solve a murder mystery, and I think it's got tiny metal pieces, which I've annoyingly hidden underneath this N, but I think it's these things. So Clue.
Yeah, looks like it. Looks like revolver and so on. Yeah.
Right, so now we've got 3 left. We've got some cards with black borders.
That one's Dominion. I used to play that a lot as a child.
Oh, brilliant. Okay, does anyone in chat know this? I did not recognise Dominion last time I had a quick look at this puzzle. Spoilers, I've had a look at this puzzle before. Is that Dominion? Yes. Where's Dominion from? Look at that board. Anyway, okay. And then I think this S... I've got an S and an E that kind of overlap each other over here.
Well, we have 2 games left, right?
2 games left. One of them is Risk and one of them is called Stratego. Opinions on. Yeah, so chat thinks that E is Risk. Oh wait, well, hang on, do I agree with this? So there's all these sort of country regions on the S one. That seems like Risk to me. Well, we think it's S and E in some order. Let's have a look at these letters that we've got across the top. My pen's... I think I've possibly broken the internet. No, we're good. I've got MI something S, INGON something S. So I think my preference is to put the S over here. Yeah, good. To ask a question in chat, math scores. If you took math in 2024, you should be able to get your score from the test registration portal. They've become available today. At time of recording, time of being live, I suppose.
By Back when I sat my math exam years and years ago, we didn't used to get them.
Yeah, well, they registered through a test portal, and this year they can get it through the test portal. But it's yes, there's an email going out to candidates today to explain that. But I can see it in here as well. Yes. The E is risk. E is S's risk, I think, with the countries. Okay. So someone in chat has spotted that this spells missing ones. I'm going to put in text over here. Somewhere. Nice. Yeah. The answer to this puzzle, though, is a single word. So we're not done, I think. Because unless misingones is a single word, I mean, need to keep going, I think. So, hard question. What next? And that's a hard question that comes up in maths problems as well. Someone in chat says, good luck to anyone doing collections tomorrow. So for reference, for collections are the Oxford mock exams. So I think that's someone at Oxford giving advice to other people at Oxford who are watching the Maths Club stream. Hello, current students.
Collections tomorrow for the first time in my life. So.
Oh, yeah, what, you're marking collections, or you were taking? No, you're not.
No, just invigilating.
Oh, invigilating. Right. Okay. So
I've never done it before, so I hope everything goes to plan.
How hard can it be? Invigilating mock exams, doing it's a mock exam. Maybe people watching have got mock exams as well. If they're in year 12 or equivalent, they might have something like that going on too. Yes. Right, so we've got this mysterious text, missing ones, that feels like we're onto something because it's at least English if you put a space in between the G and the ones. We need one more idea, I think. So I'm going to wait for chat to have one more idea, reminding chat that they can be anonymous and there's no such thing as a bad idea. And then as advertised, I promise this is going somewhere. Tell me though, if need be, have you got ideas about? We should let chat suggest stuff, but if need be, have you got ideas about what missing ones might mean?
Well, I'm not fully sure, but I'm supposing we should be looking for something in the picture that's missing. I'm not sure what.
Right, yes, something missing. One's plural, so which is right. One means singular. One's plural. Oh, I love the idea that it could be someone called Miss Ingenies. Yeah. Oh, objects that are missing ones. Right. So if you look at the Scrabble tiles, maybe are the letters worth 1 point missing? No, there's like an AOE. Okay, but maybe that's not what Aaron meant. I think yes. Uno's missing yellow cards. Says an anonymous person. Yes, that's true. This is not a full set of Uno cards. It doesn't have any of the yellow cards. I'm going to make a note of that over here. Anything else? Missing ones plural. Oh, spelling. My spelling is missing. Let's go over there. I'm going to I'll leave that there in case anyone's thinking. Yes, Catan is missing. It's missing rock. I think in Catan. Did you say you played Catan recently?
Yeah, there's also a rock, but isn't there? Yeah, no, that's not rock. Yeah, there's also rock.
Yeah, and there's a slight connection from a different anonymous person. So in Catan, maybe they're called oars, just in case it matters. Uno is Spanish for one. Mono mean one. Oh, have you spelt mono out of? I've only got one O at the top. Oh, so if we're looking for a single word, maybe we could take some of the letters, but I quite like the spelling this, and they do seem to be some missing things. I'm trying to keep the screen still, just in case anybody is looking at the Scrabble letters. Oh my goodness. Oh no, those are the bananagrams letters. Okay, Mattis gets to be maths at Magdalene. Cool. The bananagrams are maybe missing Y. Oh my goodness, here are the bananagrams. Ooh, are they missing? Yes, they are missing Y. Okay, so this is kind of maybe have all 25 other letters. So just a capital Y. And we've got an order for these. Yes, there's no kings in the chess. There's everything else, right? There's a couple of pawns, a couple of knights, a couple of rooks, a couple of bishops, a couple of queens. So maybe if we write down K for king or something, is that how it works in chess? I should have looked that up.
I think so, yeah.
Yeah.
Okay.
The tedious part of this puzzle is if we complete the puzzle, we'll probably need to go. I'm probably going to need to go and look up a list of stratego pieces or something. I suspect that a stratego piece is missing, and goodness knows. But we've got quite a lot of people live in chat. Maybe I don't know. Maybe I'm being rude, and there's like the world champion of stratego is with us and can let us know. The thing I want to point out, I suppose, is that if you keep doing this, you can, by the way, discover this is enough ideas to finish off the puzzle. I'm going to stop there so that we're not spoiling the end of the puzzle. I guess combined with the idea that you maybe only want the first letters of things like this Y and this O and this Y. There's some stuff in between, right? Because we have Uno first, Catan second, and Bananagrams was last. So we can build this kind of second phrase. Yeah, right, good. Okay. So if you want to finish that off, you may need to look up a list of what's in Sushi Go or something, at which point there's some slightly tedious work. Yeah, sorry, I should zoom in, right? If you're playing along at home just off this screen, here's a picture of some Scrabble pieces. It looks like there might be one missing, but they're not in order, so... the point I want to make is that, well, this is going to spell a second phrase. It's looking at the same image, but in a different way. Almost like you've got one kind of lens that, I don't know, I'm thinking of 3D glasses where you have like a red lens and a blue lens, and the red one lets you see some stuff and the blue one lets you see some other stuff. The first time you look at the picture, perhaps you see the shapes, you see the letters that they're arranged in. And then the second time you're looking at the kind of actual content of what's in there. Forget the shape, we're just looking at which letter of the alphabet is missing. I agree, I think the letter U is missing. Well done, people playing along in chat at the same time as well. So kind of this idea of looking at the same thing in two different ways to discover information along the way works here to give us this second phrase. Chat's doing really well. I sort of wonder whether chat can... Chat's probably going to have to go and look up stratego pieces though, which is not going to be fun. Let's do that. Can I bold a single letter? Yeah, I guess I've told chat that it's first letters. Oh my goodness, I can't remember what risk is missing. There's loads of them. Right, okay, there's too many. We're not doing all of them. We've exhausted the fun of doing this puzzle, I think. If you want to finish off, it's on the Jane Street Puzzles website, which, just to show you one more time, is over here. If you search for Jane Street Puzzles, you can find this picture. They also have their solution up here if you want to just see the answer. And a bunch of other puzzles. Their policy seems to be that they're releasing one puzzle every month, and when they release the next one, they release the answer for the previous one. So if you wait a month on any particular puzzle, you can see. Some of them need a computer to help you with, a bit like Project Euler. Do you know about Project Euler?
Yeah, I did a lot of them when I was in high school.
Cool. So Project Euler is another website with maths puzzles where there's so much calculation that you need a computer, or lots of some sort of search that you need to organize intelligently, but then get a computer to actually do. Okay, right. This idea about looking at the puzzle in two different ways and combining information, that's my problem-solving strategy as advertised in the YouTube description or whatever. Several puzzles, one strategy. Right, time for another one. We're moving on from this one. I will leave you at home to discover the second phrase that's hidden in the same image. If you're interested in that sort of thing, do find out there was a previous Maths Club episode where we looked at the same picture, I think 3 times. They'd managed to put 3 layers of information into the same picture. I sort of suspect that this is from the same mind, but who knows? Right, okay. I want to show you another puzzle. And this one, I'm scrolling, but I don't know why I'm scrolling. It's physical. I've got it on my desk. Let me show you. Right, okay. I don't really know now if chat is now just going to go and look up Stratego pieces and tell me which one's missing, or whether chat's going to come along for this bit. Right, here we go. We should cut to reality. Here we go. Oh, there it's going. It's going. I think it happened. Yes, got this. Here's my desk. So I have this physical puzzle. It's called Snowflake Shuffle. Oh, a little bit of unboxing content, because I know YouTube loves that. It's got pieces. So it's a bit awkward, isn't it? I need to be there looking that way, but my hand's down here. It's got this nice snowflake with, it's got these holes for pegs and a large number of pegs. And it's a sort of solitaire puzzle. The idea is that you start with pegs in places except for the one in the middle. So I'm setting it up by putting pegs all the way around the outside except the middle one. A move in this game is to jump one peg over another one. The jump so the jump has to be along the lines of the puzzle. You can't just pick whichever two pegs you like. And when you do the jump, you have to jump a peg over an existing one into a space, and doing that removes the one that you jumped over. I'll give you an example in a second once I've... Gosh, it's taken me much longer than I thought to place 18 physical pegs. There we go. Never do things in the real world. You never know what's going to happen. There we go. Good. Right. Is Tamio still here? Yes, you're still with me. Good. I've managed to keep Tamio and reality, and I think chat is still going. It's all happening at once. Maths Club. Right. Here's a move. So if I want to do a jump, I have to jump into an empty space. There's only one to start off with in the middle. So I could jump this peg, jump over here along a line into the gap, and that removes this peg. The aim of the game is to remove as many pegs as possible. So we start with 18 pegs. We would like to remove as many as possible. So my second move along the lines could be something like this. Jumping this peg over this one into the gap, jump like this, removing this one. And now it's over here next to this one. So now maybe for my next move I could jump this one back again. Jump over there and remove this one. And sort of keep going. But I have to go along the lines of this snowflake-shaped puzzle. If you've played a kind of solitaire game before, maybe you've seen something like this as a game mechanic before. But that's the plan. I'm going to keep going, and I think because of the pressure of doing this live on YouTube, I'm going to do quite badly. Yeah, this is going terribly. I've got these ones around the edge that are a bit stuck. Hopefully, if I do this slowly and badly, that gives people more chance to tell me in the comments that they could do a better job. Right, what are we doing? So if I go over the middle one, that's allowed. They're kind of all connected around the middle. That's good because it's got out towards one of these outer ones, so then I can come back in. Removing this one, I can go out this way. What do I want to do? I guess I want to go over here, removing the one I jumped over, and then it's getting a bit tricky now. I'm going to go over this one, removing the one in the middle, and finally go out here, and then jump back in again. But now I think I'm stuck because I've got 4 left. But none of them are next to each other. The jumps have to be adjacent ones jumping over, removing the one in between. Oh, I should have done that first. That was a great animation to do. I think there we go. Jump into a space, remove that. Should have thought of that rather than just giving you the top-down view. Right, okay. So I've got 4 left. The maths question, I suppose, is can I do better? Could I have fewer than 4 left at the end? If you'd like to play along at home, something you could make, I'm lucky to have this kind of physical plastic snowflake thing. Something you could make is a little grid drawn on a bit of paper. I'll show you how to draw this snowflake shape if you like, but you can draw a little grid on a bit of paper and have, I don't know, grains of rice or scraps of paper or counters or beads or paper on top in the places so you can mime out jumping things over. I think this is a good puzzle because it looks deceptively simple and has, I promise, some interesting maths. But the rule of these things is that we have to have a go at it first before I show you the maths behind it. Tell me, any ideas, or is this making you think of any maths? You can say no, it doesn't look like maths.
Well, I'm thinking, firstly, of course, you can't have fewer than one left at the end because the last one by itself can't eliminate itself.
Ah, yes, we'll never be able to remove the last one because the removal mechanism needs a jump to happen, which involves having two.
Uh, it seemed to me that as we were going through, the most important thing to keep track of is eliminating those six sort of isolated ones at the edge,
Yeah.
since those are the least connected somehow.
Yeah, so the snowflake has got these kind of 6 points around the outside. It's got these ones that are not super connected either. It's got these ones around the outside. Mateus in chat says that we should be aiming to constantly set up the outer pieces. I guess sort of want other advice about when one from the outside jumps in, it always has to jump over one like this into the middle.
Mm-hmm.
And when I tried just now, I had one in the middle for ages. So maybe I should have focused on trying to clear that out to do better, so that I could jump more of the ones from the outside in. Let's see whether can I do a kind of poll or something? Yeah, I can do a poll. I've got 4, so I'm going to go for a multiple choice quiz. It's going to be what do you think the minimum might be? It's going to be sort of the minimum number of pegs left. Tamio's convinced me that it's more than 0 because you can't just have one peg jumping over itself at the end. And it's definitely less than 4 or equal to 4 because I've done that. So I guess the option should be 1, 2, 3, and 4. There's a vote in chat. There we go. Aha! It's only showing 1, 2, 3 on the screen, but I'm pretty sure I put 4 in there. I know how numbers work, I promise. I'm still voting for how you might be able to get down to. Interested to see how that goes. I have also, on my screen at least, broken chat. So got Tamio, got the real world. Think I'm live. How have we got? Oh yeah, we've got voting, we've got chat. Good, okay, I've set it. Accidentally set it to popular, not recent. So people are voting at the moment on how many pegs we might be able to get down to if we really tried. I think worryingly, I've got 2 of these outside ones left over. Right, I suppose I should probably have another go at it, right? Possibly led by chat or Tamio or both. It's a little bit backseat driver because I've got the physical thing in front of me. Do you want to go? Do you want to have a go at it? Okay, worst case scenario, we get more than 4 and don't learn anything. Best case scenario, we get, well, I don't know, 1 would be best case scenario. Part of this, I suppose, is going to be working out a system for how you're going to tell me which one to jump. We've got the center.
Complicated.
Yeah. Maybe this is not a good idea. I'm sort of not sure it's good TV anyway. Chat's voting. I'm gonna have a look at the vote in a second. Chat has quite a lot of faith in us, by the way. Chat thinks that we could get 1
So
as a way to get.
I've been trying to think of a way you could show that you can't get 1 at all, and I'm starting to think that you can do 1 just because I can't think of a good reason.
That's a real mathematician sort of. I can't think of a reason why it wouldn't be 1, so maybe it is 1. I like Enora's suggestion, which is to go back to not reality and see if we can get chat involved by having this on screen over here. So here's a diagram of what the puzzle. So if you draw, oh, excuse me, that's horrible. If you draw 2 triangles, points wherever they cross. Oh, there's a little bit of lag on my drawing as well, which is putting me off slightly. 1 in the middle, and there are these spokes that go through there, out here. 1 in the middle going across, and then a diagonal coming down this way. So actually, when I draw the diagram, I haven't made the spokes. I haven't drawn all the little hexagons and things around. When I drew the diagram for the first time, that was when I realised that there's a lot of equilateral triangles in here, right? The physical thing's coloured in the middle, it's all kind of solid, but there's a lot of equilateral triangles here. The length of these things doesn't matter, so maybe interesting. Okay, right. In order suggestions, I write letters. We're going to do our best. Oh, we got 25 minutes. I think that's enough to play this once. Oh, this is like I did quite a while ago now. Maybe Tamio's seen this. I'm not sure. Chat will have seen. Chat might be aware of the lore, I suppose. There was a Twitch stream that played Pokemon collaboratively. It was called Twitch Plays Pokemon. It's people in chat voting for what they would do in the Pokemon game, sort of automated in some sense. We're going to have a go at that. Oh my goodness, this is a terrible idea, isn't it? So I'm going to put pegs on 18 of these spots. And then the chat message we need, I think, is which letter of the alphabet is jumping over, because there might be multiple choices, jumping over which other letter of the alphabet. There should be one on I as well. So your chat message might be HI or H jumps over I. I reckon I can do this. Right, Twitch plays solitaire. These games are called solitaire, which means one player or on your own. We're a maths club. We're going to try and do it together. Let's see if that even slightly works. There's also going to be clashing chat messages that are going to work together, which was a thing in the Pokemon game as well. Do look it up. Someone in chat just says hi in capital letters. So hello, good to see you. Nice to join us. Yeah, you've missed a little bit. We did a Jane Street. Oh wait, no, that's them jumping H over I. So jump H over I. Okay, good. We now have nothing out here because it moved, and we have nothing in I because you jumped over I. Right, and we've got something on J in the middle. Best letter of the alphabet. I think it's quite an important space. What next? We've got, just counting how many possibilities we've got, I sort of thought, when I first saw this, I thought, well, can I just make a decision tree, right? You know, branching through all the possibilities. How many things can you see for the next move?
At least like 3. RN, BE, and KJ, but BE and RN are the same, just symmetric to each other. So basically, you have 2 choices as far as I can tell.
Yeah. Oh, there's a symmetry. Very good. Yes, I hadn't thought of that. Yeah, so your branching process, and B over E and R over N are kind of the same. I'm just going to get you to spell it out, sorry, because I can't tell. Probably chat is ahead of me, but I'm a little bit thick. They're the same. I hadn't spotted this. They're the same because of symmetry. But
yeah.
Okay, let's jump over this. So chat is a bit split between RN or BE versus K over J. There's 2 votes for K over J, so we're going to do that next. Chat, we're doing great. We've removed 2 pins out of 18. What next? So in terms of branching processes, right? We've now got at least 2 options. No, we've got 4 options now. Wait, no, 6. But kind of maybe 3 because we're nice and symmetric. I can see things like Q over N, R over O, S over O. Yeah, he's kind of moving something into the middle. We've got, so Matthias has committed 3 moves, some of which are illegal. What can I see? Some votes for S jumping into J. I like jumping into J because, I don't know, I'm not trying to steer chat in a particular direction here, but jumping over this one feels nice because we're getting rid of some of these tricky ones around the outside. What next? Oh, this is, touch wood, right? This is going better than I thought. Except we're maybe diverging a little bit. That people at home might be shouting at the screen that they wanted a different move 2 moves ago, and now it's too late. What have we got? If you do RO, the RO's gone. Oh no. There's a couple of votes for IK next. I jumping to K, I think, to clear up the middle.
You IJ, then next turn you can eliminate another corner.
Yes, I like that. Okay. So I over J, I like. You got a choice of corners, I suppose. We're no longer symmetric up and down, so maybe it matters. I don't know. So the annoying thing about branching processes, you never really know. Are the branches going to turn out to all the same in the end?
If you do C over F, the whole diagram becomes symmetric again, which is fun.
That is quite funny. Maybe we should do C over
We
M.
did something very
There's
asymmetric, and somehow we're reaching another symmetry.
I would like it to become symmetric again. I don't know why. It just feels like
More likely to be solvable, I guess.
maybe I don't know. So L jumping to J has got a few, or BE. Well, BE is interesting, so that we can get rid of M. Where's M? Oh, trying to get to. So they're worried about. This is. Excuse me. This is an anonymous person in chat. Is worried about not the outermost ones, but the 6 on the kind of points here, which we haven't dealt with at all yet. I quite like that. Let's do a couple of those.
Sure.
I'm allowing 2 moves, I think. Oh, sorry, Mario. There we go. B jumping over E, and then we can deal with M by jumping it. Oh, we get a choice. I'm jumping ahead. I should let chat help. This is nice now because I can see old chat messages, and some of them still work. Like Q jumping into J is still an option, so I can do that one. Maybe we could do it in parallel. Look. M jumping over I would be allowed still. Maybe we'll have that one. I'll do that one too. Sorry if you're typing in chat. So focusing on the outermost ones is good, but we do also have to do, if we want to get down to 2 or 3 pegs, then we've got to deal with these ones like M as well, which is why I'm pleased that we've got that.
How about similar to what we did before, maybe G over K and then R over G, or over whatever used to be G?
What do you mean R over? Oh, so R over this O thing in here.
Yeah. Where G is moving to, I mean.
Yeah. I'm going to pause slightly to see if we can form a quick consensus. What do you think, chat? We could do a G over K and then R coming in to deal with 2 of these. We've already done the ones around the outside over here, so maybe we're then focusing our efforts on the rest of the puzzle.
Although that's quite an interesting thing. I wonder if this technique seems to just deal with 2 things, and maybe something like that works more generally.
So E over E to O to set up C to J. Inora was happy with this though. GK. Yeah, I've got a couple of votes for GK. So G jumping over K. And I think that means that they want to jump R over O next.
And we've dealt.
Sorry to project on chat. At one point, a couple of years ago, somebody compared the live stream to those video game ads where somebody's playing the video game really badly to trick you into downloading the video game. Somebody compared my maths to that. Doing it so badly that you're shouting at the screen like, oh, no, let me have a go at doing the maths.
I find those that's very effective just because I feel such a need to solve the puzzle game.
Let's briefly. Oh, yeah, we still have it. We've got symmetry back again. Joe spotted the symmetry along the QC line along this diagonal, just randomly, which we're now going to break by doing, I think, F over N.
F over
Can't
N.
even see N. Oh, F jumping to N. Sorry, maybe.
We're still symmetric though.
Yes. I think I just locked that one in place, which is not. Yes, I did. There we go. F to N. Still symmetric. That's quite nice. Oh, but we've got these side. Oh, I'm looking at an angle now. We've got these side bits where we're going to have to break. We're down to 8 pegs left. I really want chat to do better than 4 now. I want them to do better at the puzzle than me on a first go. There was that sequence. E G. Have I stuck with this? E G. I've not stuck with this. Sorry, chat's got 3 moves in a row, and then G O to get rid of P. Oh, that looks clever. I can't go back. And it says A E and then K R to I to sort of clear out this. Oh, they want to get rid of one of the outer ones again. Seems all right. I think not a disaster.
Now, if we do K over J, aren't we stuck or almost stuck?
Kind of almost stuck, maybe.
Like if we do K over J, the only move we have is I over N, and then we're stuck.
Which would leave us with about 5. Can we do better than that? Can we do better than that from here? I can't remember what we did last to undo it. Can we do better than 5? Not sure. So N over J maybe to set this up, and then go over here, and then I think we're stuck with 5 at the end. I think we might be might be stuck with about 5 pegs left over now. I will do n over j because it's in chat. I think it might be inevitable now that we've only got about 1 more move. Oh no, not true. Not true. L over k next, right?
Yeah, L over K.
Sorry, chat. I should have let chat spot the thing that's better than. Should have let chat do the thing that's better than the thing I was talking about. L over k is not bad. I think it's better than k over f, because k over f we get stuck up here.
Yeah, no more moves.
Yeah, well, we should be trying to get rid of the outer ones. We said.
Mm-hmm.
Maybe L over k. L over k is pretty good. And then finally,
One thing left to do.
I think it is only one left. F over j.
And somewhat mysteriously, we have yet again 4 pegs.
Yeah. Oh, L over fn. I make it 4 pegs at the end, Matthias. Was LJ what we did or what we suggest? Yes, L coming in. That's Jack suggesting something that we did. So at least consistent with what people want at the end here. Oh, okay, great. So we've been left with quite a few pegs at the end again. Actually 4 again, which was partly my plan, but well, we'll see. No spoilers, I suppose. I want to tell you about solitaire. Because I've previously seen some maths that someone showed me for regular solitaire. Solitaire games are normally on a square grid. This one's got loads of triangles, so we'll talk about this one in a second. But I want to show you something for square solitaire. Like, I could just tell you the answer to this puzzle, I guess, but I think it's more interesting if I tell you about square solitaire, because there's a chance that you'll see square solitaire in the future. It's a thing that people do. I don't know, grids with squares. Same rule, you can jump things over things. So if you have 2 pegs, what you can do is jump 1 over. You can only move in cardinal directions. You can't go diagonally. Let's write that down because somebody is going to ask me in about 3 minutes. And I'm going to go no diagonal moves. So solitaire is kind of well known enough that people have thought quite a lot about what you can and can't do in solitaire. The idea is that so you can jump over here and that will destroy this one in between. Gone. So I want to show you the lenses for this problem, the different ways of looking at the problem. I've got them under here. So this is where I keep my lenses. The lenses look like this for this problem, which is a little bit arcane. But this is something I can put over the top of the grid, so that over the top of the grid to reveal some sort of structure behind the moves. And I'm getting a little bit of CPU lag, but I'm going to trust that it lines up. There we go. Okay, so I can colour in some of the squares yellow, and then the rule is that yellow counts as 1. Blank counts as 2. And the result is that the oddness or evenness, how do you spell evenness? What am I going to go like that? I'm going to have another go because I've got a red squiggly line. This is not a spelling live stream. Nobody's come here for spelling. Oddness or evenness doesn't change. What do I mean by that? Here's what I mean by that. So if you have 2 pegs on a square solitaire board, maybe like this, with the yellow one counting as 1 point and the blank one counting as 2 points. Okay, so the total here is odd. Then after you do a move, you end up, well, in that example, you end up with a peg on yellow. That counts as 1 point. And this one's gone because it moved. This one's gone because it got deleted. So you get an odd total. It was 3 points before, now it's 1 point. But the oddness or evenness of that total doesn't change. Let's put more words in. So this is kind of quite an arcane concept of something that doesn't change, something you wouldn't really spot when you first meet solitaire on a square grid. This idea of, yeah, people in chat have seen parity, hooray. Oddness or evenness is sometimes called parity, but something you wouldn't spot. But it is actually true that whatever move you're thinking about, no diagonal moves. There's your 3-minute warning. Whatever move you're thinking of. So this one jumping over here. This would be 2 points changing to the blank counts as 2. It doesn't matter what move you do. You get the same oddness or evenness of the total. I can't remember if I just said this word, but there's a word for this kind of hidden quantity that doesn't change throughout the process. Do you know what that word is, Tamio?
In fact, it's the name of our math society, basically. It's an invariant.
Yeah. Which is why I picked this puzzle as something to talk about when I had someone from the invariants on. An invariant is something that doesn't change. It can be something really weird. This is really hard to spot when you're thinking about solitaire, that if you colour in the squares with 2 yellow diagonals and then a blank diagonal, then 2 yellow diagonals, then a blank diagonal, and you count the yellow as 1 point and you count blank as 2 points, then the oddness or evenness of the total score doesn't change as you do the moves. But the power of the invariant is that you can say, okay, so if in my original setup, maybe the parity of this thing is a massive even number. Well, as you do your moves, you're going to end up with an even number at the end, which could be quite powerful. It could tell you something like that. I guess maybe it's better if I say odd, right? Because
I think here it is even.
Yes. So here, what have I got?
An even number, at least one has to be 2, right?
Yes. Well, I guess I have something slightly more powerful, which is a second lens, which they can see. You might be wondering where the blue squares come in. That's because this choice of lens that I've put on with the yellow, yellow, blank, yellow, yellow, blank, well, there's different ways to do that, and they all work. So long as you have 2 diagonals and then a gap, it'll always be the case either your piece is jumping into the gap or one of the pieces was in the gap and it's now been deleted along with something that wasn't in the gap. Keeps the oddness and evenness the same. Which means that I also have this blue lens. Oh, that wasn't the piece I thought was going to move. It's done it again. Right, okay, I'm going to put the blue lens on top of the grid over here. Oh, it's brought the dots with it as well. Great. Pretty handy. Which gives us this different interpretation. Same rule, coloured in square counts as 1, blank counts as 2, but it's a different interpretation of how to score the points. It's a different invariant. The really cool one is what happens if you apply both lenses. So thinking about the problem in both ways, to identify for the diagonals which one, if I score using the yellow squares to create a score for where the pegs are, I get one value for the score. And if I look at the blue squares, I can create a different score for what the pegs are. So for this combination of pegs, at the moment, I would say yellow, yellow, yellow. So my yellow score would be 3, and I've got blue, and a blank. So my blue score would be 4 because non-blue counts as 2 points. So at the moment my yellow score is odd and my blue score is even, and neither of those things can change as I do moves. So that tells me quite a lot about the final configuration. It tells me it must be some combination where the blue score is still even and the yellow score is still odd. If there's only a single peg, that tells me enough to work out where it is or what kind of diagonal it's on. There's kind of 2 different ways of looking at the same puzzle. Good. I don't think I made much sense there. Maybe I need a practical example. Yes. Well, maybe I want to switch. So maybe the square one is not what people want to see, because of course our puzzle in the physical world that we were just doing is not square. I like this idea though, that if you colour them in so that you go yellow, green, blue, then you can kind of argue about the colours. And it's not quite conservation of colours. It's slightly more complicated than conservation of colours, but it's almost conservation of colours. I haven't quite found a good way to say this thing, that the coloured in squares count for kind of an odd amount of points, and the ones that aren't count for an even. Maybe this should be 0 instead of 2. Doesn't really matter. Anyway, maybe 0 would be much better actually. Anyway, we've got this kind of for our puzzle with the snowflake. It's this kind of hexagonal grid, which is quite nice. I was going to do this as a puzzle, something to do at home, but I wonder if maybe it's easier, given we've got about 5 minutes, I might just show you. I guess, quick question for Tamio and the audience. Do you reckon you can colour that in a similar sort of way? Yeah, yellow, green, blue in some sense. So that what I'd like is for any jump to involve a yellow square, a green square, and a blue square. It's not obvious to me that you can colour it in so that that happens.
It seems a bit more difficult on a first viewing, because somehow the natural way to do it is diagonal by diagonal.
Yeah, so I can't go diagonal along here. Yes, so to do diagonal stripes like this doesn't work because my sideways jumps would involve a yellow square, a green square, and a blue square, but the ones along the diagonals would involve 3 yellow squares, which then does change the oddness or evenness of the yellow score when I do a jump along the yellow direction. But I worked out you can colour this in. I'll show them, I guess. You can colour this in so that every possible jump involves a yellow square, a blue square, and a green square. Why am I saying square? A yellow space, a blue space, and a green space. So whenever you do a jump, it's kind of 2 possibilities. You either jump over. Oh, well, never mind. Look. A different way of saying this is you look at your initial configuration, you count your yellows, you count your blues, you count your greens, but it's only the oddness or evenness that really matters for each of those. When you do a jump, you'll move. Oh, what am I doing? So if I do a jump into that space, then I'll kind of destroy one of each of these and create a green. Yellow plus blue is green, right? Or maybe I'll do something that kind of breaks it down. It's a little bit like chemistry or something, right? The way that these things combine together and join together. So you can kind of combine together a yellow plus blue makes green. And there's some sort of conservation going on here, even if it's not the pegs being conserved, it's like the oddness or evenness of what's going on. You can turn this into a proof, and I don't think we've got time for the details, but if you colour in the snowflake board like this, then you can turn this into a proof that you cannot be left with a single peg at the end. So here's the snowflake board. You cannot be left with a single peg at the end. Let me put the points in for the starting points.
I think it's very cool that actually the original game is the same as this configuration.
Yeah, it's a little bit disguised because the far out spoke ones are blue, and also because some of the jumps are banned. There's some places where there's no line, so that jump's not allowed. It would conserve this kind of property that I'm describing, but the snowflake doesn't have that line, so it's not allowed.
Somehow adding even more available jumps makes the game even easier. So if you can't do it even with these more jumps, you can't do it with fewer of them.
Yeah, so the number of each of these blue, green, and yellow things is even to start off with. I'm missing this central. I keep saying square. Central point is not there, so I've got 6 of each. And then as you do the jumps, what do I mean? It's not quite true, the parity. So it's not the parity of each of these, is it?
I think it's yellow plus green's parity is conserved, and also blue plus green's parity is conserved.
Right, thank you. Yeah, there's some combination of the parities. It's not as simple as saying the number of yellow ones is conserved.
Mm-hmm.
That's ridiculous because the very first jump I do will destroy some sort of yellow one and a blue one, but create a green one. So there's kind of some conservation rule going on. Cool. Okay. So there's some sort of conservation, which means that if you get exactly 2 pegs left at the end, I know that they have to be on the same colour. Sort of no yellows, no blues, 2 greens left over at the end. And a single peg would upset the balance of what's going on overall here. Good. I think I've done a pretty poor job of explaining what the invariant is, but hopefully given people enough clues that they could maybe work it out at home, maybe. The sort of possible, there's only a finite number of things that could happen in terms of yellow, green, and blue as you go through here. Like chemical equations, yellow plus blue gives you green, but removes if it's yellow and blue. There's something being conserved behind the scenes here, which is called an invariant. There we go. There, right. I think that's what I've got. There's sort of a couple of puzzles where the problem-solving strategy is to look at it in different ways, and then if you can, combine together that information to find out a kind of hidden information that was in the puzzle. That is my cheesy link. Yes, it didn't win the vote. The vote was 10 votes, but I think one was pretty popular, that we could be left with a single peg standing alone. Sadly not in the solitaire puzzle. Oh, and obvious question, can you actually do 2? These invariant methods don't show you that something's actually possible. Even if you've proved that 2 is, once we've gone with a complicated reason why you can't do better than 2, can you actually have 2 pegs left over? Well, got to go and actually do it in order to prove that you can do it. So I'll leave that one as a kind of homework thing, I think, if people want to try actually jumping down to get 2 pegs. Who knows? Might not even be possible. Maybe 4 really is the minimum. Oh, that's cheeky of me. Oh no, I've made it sound like I don't know what the answer is. Maybe that'll trick people into doing the puzzle. Good. Okay. Tamio, is there anything? We're about to wrap up, I think. If there are other puzzles that you want to promote or other stuff that you think they might like to know about, here's a good moment to promote some other stuff.
Not particularly. I think just these kinds of parity invariant problems are very pretty. Always, it's I always find it fun how once you get the right invariants, typically the problem sort of just falls out and it just works. I like that kind of a problem, if that makes sense.
Yeah, it can let you cut right through all of the complexity about thinking about where the pegs are, or thinking about are they far away or near the center. Avoid you thinking about the kind of specialness of the center entirely to get you through to just invariant at the end. Right, I've remembered I should plug the further reading notes. So if you go to the Maths Club website, there's a link somewhere on the screen and in the YouTube description. What we're trying to do is each Friday, so after the live show, to make a kind of blog post with links to other stuff and corrections or things we forgot to say on the live stream. I did one last week for the episode with Beth and the calculus. I'm going to try and do another one tomorrow, Friday, to type up some notes about invariants and the Invariants Society. But other than that, I think we're going to call it there. Thank you very much for being on the show, Tamio. Thanks for people in chat joining in. We will see you in 167 hours for another episode of the Oxford Online Maths Club. But until then, have a good evening, have a good weekend. Bye from me.
Bye-bye.
Take care. See you around.